Weekly Contest for 67. Well, this contest was pretty much of a joke because we had two easy problems on the list. And yeah, but the third and fourth was obviously hard. And let's get into the problem. So here's the first question of LeetCode Weekly Contest for 67. Earliest time to finish one task. What do they say? So you're given a 2D array tasks. Okay, we are given a 2D array. Let's say it's 1, comma 2, 2, comma 3, 4, comma 5, and so on, right? Now what are you supposed to do? You're supposed to find the minimum time out of all the tasks where a particular task completes the minimum amount of time. So what does it mean? First of all, this indicates the start time and this indicates the units of time to finish. Okay? Now we know that this particular task will complete at time 3. How? It starts at 1. It takes 2 units of time to complete, so 1 plus 2 is equal to 3. Like that we process for everything. So this will take 5 and this will take 9. Now this time corresponds to each task's completion. What are you supposed to do? You're supposed to return the minimum amount of time taken for any task completion. So isn't it obvious that we should directly return the minimum? And that's the answer. So this LeetCode Weekly Contest, as I mentioned, was pretty much straightforward. So you just process the sum of each unit of elements inside the task array and you return the minimum. So here's the basic idea of the algorithm. You take m and you initialize it to infinity value and you run a loop inside the task array and let's store the first element for each because it's gonna be stored in this format x comma t, right? So you can name it in any way. I named it as s and t, s as the first element and t as the next element, the second element inside the particular index inside the task, and I compute the minimum amount of time taken according to that. That's pretty much it. So here's the first question. We start by initializing s, and in Python you can directly do this one line or sum of I for I in task. This is nothing but equivalent to adding each and every indices sum, elements sum in a for loop, and we directly return the minimum of it, and it should be working fine. Let's submit it. Yep, all set. So let's move on. So here's the next question. Maximize sum of at most k distinct elements is the question. You're given an array nums and integer k. Okay, let's take them. Let's take the direct test case. So that's 84, 93, 100, 77 and 90. And then integer k. That's 3. What are you supposed to do? You are supposed to return the k greatest elements, an array of k greatest elements, also ensuring that all the elements are unique. How do you do that? So first of all, by taking a glance, you can understand this is the first greatest element and this is the second greatest element and this is the third. And 100 is not equal to 93, 93 is not equal to 90. There are no repetitive elements. So we can directly return the answer as 100, 93, 90. So this is clear. Now what if the array is like 100, 101, 100, 100, 99 and 90 and k is equal to 4. First you'll figure out the k greatest elements. So these are the k greatest elements. This is the first greatest, second, third, fourth. But as I mentioned, all the elements must be unique. So we can't consider this, nor can we consider this. Only 101 and 100. And then we move on to the next greatest element, which is 99. And then 90. So the answer for this question would be 101, 100, 99 and 90. So the understanding is clear. Now how do you do it? obviously you'll have to sort it to get the k greatest elements, or another way is using a heap, but sorting is much more user friendly, so we'll just sort it out. So this is the array which we get from the previous test. Is one sorted out, 93, 90 and 84 and 77, right? Okay, we have got the array. Now you can return directly k greatest elements. But what if there's an element in between which is repetitive? Now there are two ways. One is a brute force, a very naive idea which you can use, that is putting all the elements inside a set. In the previous video I explained a set just in brief, so you can check it out, and then converting the set into a list. Let's say this is x, set of x, and then sorting the list, and then after sorting returning the k elements. So okay, this is fine, but it's very naive and doesn't, you can solve it in O1 space. Now how can we solve it in O1 space? So let's say this is going to be one such array, right? 100, 100, 100, 99. After sorting, this is going to be the element. Now first, let's say answer is going to be your array which you're going to return. First thing you'll do is put the first value directly inside the array, because k is always greater than or equal to 1. That's one thing. K is always greater than or equal to 1. Now when you push it in, so one value of k is already taken. So now k, let's say if k was 2, now since we have already inserted k will become 1, only one greatest element we'll have to insert. So we'll run a loop from 1 to n, that's len of the array, and we'll check if the current element is equal to the previous element. It is equal, which means it's repetitive, so we'll skip. Again we'll check if the current element is equal to the previous element. It is equal, so we'll skip. Again we'll move on to the next element. We'll check it's not equal, 100 is not equal to 99, so we will push it inside. Once we push it, it's going to become like this, and we'll decrement k, indicating that the k size has been taken. So k is equal to 0. Once we know that k is equal to 0, we will return the array. So this is that. Now the time complexity, sorting takes in time complexity of n log n at best. This is one of the time complexity. Additionally, we are running a loop from 1 to n, that is on. So as per standards, as I always mention, we'll ignore this. So answer is going to be n log n for the time complexity. And the space complexity, it's going to be on actually, because we are storing it in array answer, right? The answer we are storing. But if we do not consider that, obviously it's going to be O1, because we are not using any additional space to compute. We are only storing the answer inside the array. So you can consider it as O1 itself. And here's the next question. We start by sorting the array in descending order. Reverse equals once. One signifies that it's sorted in descending order, and we'll initialize an answer array which will store the answer, the sorted k greatest distinct elements, and we run a loop from 1 to the len of nums. And as I mentioned, the first element is the greatest element, so we'll directly insert it, and since we have inserted 1, we'll decrement k. Now if we'll check if k is equal to 0, if it's equal to 0, we'll return the answer, and if it's not, we'll process by moving inside the nums. We'll check if the current element is equivalent to previous element. If it's equal, if we'll just skip. If it's not equal, we'll append the answer, right? And then with every push inside the answer, we'll have to decrement the k. So again we decrement it, and that should be working perfectly fine. Let's return the answer, and we'll just check once. Okay, yeah, so that should work. So this is the discussion, guys. Hope you all enjoyed it. Meet you until next time. And yeah, would love if you all subscribe and do like the video.